Hello, Nascent Knights. This is Mr. Tucker coming to you live from my home. I'm coming to you today because I want to talk about classifying two-dimensional figures. Now, I'm going to be honest with you, I've taught this lesson before, classifying two-dimensional figures at school in the classroom, but honestly, after I assigned it, only 50% of the class passed those two lessons. So we're redoing it. 50% is not a passing rate. So here's what I'd like for you to do. We're going to be talking today, the entire day, about every single one of these terms. Polygon, quadrilateral, parallelogram, rectangle, scalene, isosceles, equilateral, trapezoid, and hexagon. So I'm going to stop right now and I want you to copy every one of these. You'll see you're going to need these definitions in order to pass the quiz. Copy them now. Go. Okay, let's talk about these real quickly. A polygon. Here's the key term. In fact, you notice I put in parentheses here. Poly means many. Poly means what? Many, M-A-N-Y. So anytime you see a polygon, it's a closed two-dimensional shape made up of many sides. See, oh, I have that in parentheses, many, many. You'll see that. A many line segments. A line segment is a straight line, so it has to be a straight line. Can't be a round line. It has to a round circle type. It has to be a line segment, a straight line. Quadrilateral. Quad means four. So a quadrilateral is any polygon, something that's just as any line segments, made up of four. Hey, that's in parentheses too. That's right. Quadrilateral, long as it has four sides, it's a quadrilateral. Next is a parallelogram. It's a quadrilateral, something with four sides, but it has two pairs of parallel sides and two pairs of equal length. Rectangle, we got that as a parallelogram with four right angles. Scalene, now this is a scalene triangle. I didn't write down triangle because, honestly, I think you learned that in it's either kindergarten or first grade, that a triangle is a polygram with three sides. So a scalene triangle, did I put, I kind of made this up because it's really not part of the word. Scalene reminds me of the word scattered. It's just all over the place. It's scattered. So a scalene triangle is a, quote, scattered triangle with no sides the same. They're all different. Every single side, the length is different. They're all different. See if I can make one with, these are all different sides. Yeah, that's a fairly decent one. Unlike the isosceles triangle, where you have at least 2 to 3 sides are the same, and then equilateral, there's equal, because that means they're all equal. All sides of the triangle are equal. Trapezoid, this is interesting. I came up with another Tucker way to remember that one. A trapezoid is a quadrilateral with only one pair of parallel sides. It's a trap. Ooh, write that down. Trapezoid is a trap. So a perfect example of that is this right here. Here's a parallelogram. These two lines will go into infinity forever. They'll never touch. These two lines will go into infinity. They'll never touch. But a parallelogram is a little different. It's a trap. So if I change this, these two sides are parallel, they go into infinity, they'll never touch. But these two sides, look at this, this is very different. They start to come in little by little by little by little. Oh, I'm trapped. They touched. One way to remember it. And then the last one is a hexagon. Hex means 6. It's a 6-sided shape. And through the magic of erasure, magic of camera, I can erase real quickly. And I want to talk about actually classifying these two-dimensional figures. Now I say two-dimensional figures because there's a difference between two-dimensional versus three-dimensional. And we'll talk about that next week, because next week we'll be talking about volume. And volume has to do with three-dimensional figures. And that's when we will do things, we'll be determining what's inside something. A three-dimensional figure. But that's next week. Let's stick with where we are this week. And I want to talk about classifying. And we won't be doing any computations today. We're going to classify them. What is the broadest and what's the most specific? So we're going to talk about a thing called hierarchy. What comes the highest and which is the lowest in the hierarchy. So let's start with, I'll give you 3 terms. Let's make a hierarchy. Starts off with this, then goes down to this. This is the broadest, and we're starting to go down, get more and more specific. Yeah, let's go with 4. All right, what if I was to give you, I'm going to give you some terms I want you to put in the box, in the boxes here. Let me give you the first term. Where do you think the word rectangle should go? The next one would be parallelogram. Where do you think square would go? No, how about quadrilateral? Where would that go? And then tell me lastly, where would 1, 2, 3, 4, 1, 2, 3, 4, where would square go? Look at that. Which one would be the broadest? That means you could fit many, many shapes into this one definition. So if I were to show you a shape such as this shape here, I could write that's a rectangle. Would almost everything fall into a rectangle? Or would almost everything fall into a parallelogram? What would be at the top? What would be the broadest classification of a shape? And then we're going to get all the way down to the most specific kind of shape that has to meet so many different requirements. That would be the most specific. So this would be the broadest, this would be the most specific. What's the easiest, most broadest term? I want you to fill these in now. 1, 2, 3, 4. One of these terms. Put one term in the box. Go. Okay. Here's what the answers are. You should have said almost everything, Mr. Tucker, is a quadrilateral. All you have to do is have four sides. You're right. Every one of these has four sides. Then the next is a parallelogram. Next would be a rectangle. And lastly, a square. I also didn't include square in the definitions because honestly, that's another kindergarten, first grade term that you should know. A square has four equal sides. Every side is exactly the same. That's a square. All four sides are the same. So that's real specific. Of course, that's a quadrilateral. A square is a quadrilateral because that's four sides. So is a rectangle, so is a parallelogram. But a rectangle is even more specific because it has to have four right angles. Somebody caught that. And then a parallelogram is less specific because all you need is two parallel sides. Let's go to the next one. Okay, now let's take these same shapes, the rectangle, parallelogram, quadrilateral, and square, and let's put them in a different diagram, in a Venn diagram. Where would they go? What would go, say if I were to, this outer edge, what would go right here? What would that be called? What would this second one be called? What would this third and what would this fourth one be called? What do you think this outer one would be called? The biggest, the broadest one. Try to fill those in now. Go. Okay, and here are your answers. Hey, did you get that right? On the outer edge would be the quadrilateral. That's the biggest, the broadest term. And next to the broadest would be the parallelogram. Then more specific would be a rectangle. And even extremely specific would be the square because it has so many requirements. It first has to have four sides, has to have four right angles, has to have every side be exactly the same. It has to have parallel lines. The square is extremely specific. All right, now let's classify some triangles. If you see here, we have four terms that I want you to put inside the boxes in a hierarchy type of diagram. A triangle, where would that go? Where would scalene go? Where would isosceles and equilateral go? See if you can guess where they would go. What goes where? Write them in their boxes at home. Go. And here are your answers. Your answers, you have the triangle above. Yes, that's the most general, the broadest. Yes, all of these are triangles. So that's the biggest, your broadest. And your scalene and isosceles are two different types of triangles. But there's one triangle that is a type of isosceles, and that's called an equilateral triangle. That's because the equilateral triangle has three sides that are the same. And if you remember, go back to your definitions. I asked you to keep it in front of you. An isosceles triangle has two or three sides that are the same. And an equilateral has three sides. Okay, let's see if we can quickly put these four shapes, these triangles, into a Venn diagram. Now look at the big box. The big box represents the broadest. That means that everything will be able to fit. This, all will be able to fit in this classification. So what do you think? I have a line here, so something goes up here. There's one of these words will go up here at the top, one of these words will go here, one of these words will go on one of those three lines. Fill them in, go. All right, here's your answers. Did you get them right? Yes, you did, because you're a nascent knight. Okay, we're almost done, nascent knights. Here is your test. Your test is now, we're going to use this Venn diagram to fill in where each one of these shapes go. Where does hexagon go? Polygon, quadrilateral, and trapezoid. Fill in the blanks. Put something in the blanks. This is your test. You can do it. I believe in you. Go. And here are your answers. Did you get them right? Yes, you did, because you're a nascent knight. I want to show you one thing to get you ready for next week. All right, lastly, I want to talk real briefly about everything we've talked about is really a plane figure. Class, repeat that, plane figure. Yes, plane figure. Plane figure is really just a plain old figure. That's one way to remember it. It's really just a plain old shape. Figure means shape. It's just a plain old shape. So almost everything fits into that. All the different types of triangles we mentioned today, all are plane figures. All the different rectangles and polygons, they all are plane figures. So I want to show you something here real briefly. See if you can, this is kind of a precursor for next week. You tell me right now, we're going to do this real fast, if this is a plane figure right now. What about a triangle? Is that a plane figure? Yes or no? Yes, I need you to yell it out. Yes. What about a square? Is that a plane figure? Yell it out. Yes, that's a plane figure. Let's get a little more difficult. What about, let's see, is that a hexagon or octagon? I think that's an odd. How many sides? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. That's 7. Hectagon, or what we'll call it, is it a, running out of time here, I'm sorry. Is this a plane figure? Yes. It's supposed to be like a stop sign. Oh, I see, I'm missing a side here. Now, couldn't figure out why it didn't work. Okay, now that's an octagon. These should have 8 sides. Yes, it is. It's going to get a little harder now. What about, a circle? Is that a plane figure? No line segments. Yell it out. Yes, it is. Because remember, straight or curved lines, or both. So what about this right here? What if I have, like half circle? Whoa! With a line segment, a straight line. Is that a plane figure? Yell it out. Yes. And here's the last one. Nascent Knights. See if I can draw this. Here's a cube. Is that yell it out, is a cube a plane figure? No, it is not. because this is a three-dimensional figure. It's three-dimension. And that being the case, that means it can hold something inside. And that's exactly what we'll be going over next week. We'll be talking about holding what this is, like this water bottle. Look at the water. Tell me how much water can you fit in this? How much water will it take to fill up this glass? You need to be able to calculate that. And that's called volume, where you fill up a three-dimensional figure. And that's what we'll talk about next week. See ya!